Okay, so this is a question about partial pressures of gases. And you've got a mixture of carbon monoxide and hydrogen. And it reaches equilibrium at 600 Kelvin. And at equilibrium, the mixture contains 2.76 moles of carbon monoxide, 4.51 moles of hydrogen, and 0.36 moles of methanol. And the total pressure is this. Okay, so let's go back to the equation. And the equation we've got for this is up here. Carbon monoxide plus 2 hydrogen goes to methanol. Okay. So carbon monoxide gas plus 2 moles of hydrogen gas goes to methanol, which is also in the gaseous form at 600 Kelvin. The whole idea about partial pressures is that once it's in equilibrium, so let's draw it as a reversible reaction, we have basically a container where the carbon monoxide is spread out, and guess what? So's the hydrogen. And guess what? So's the methanol. So they're all spread out. So the amount that each gas contributes to the pressure sort of depends on how many moles of the gas there are. So the first thing we need to do is find the total moles. Total moles of the gases. So we just add them all up. Carbon monoxide is 2.76 moles. Hydrogen is 4.51 moles. And methanol is 0.36 moles. So we're going to add all these up using our handy device, a calculator. And we've got 2.76 plus 4.51 plus 0.36 gives us 7.63 moles. Right, and then we've got to say the Kp, the equilibrium constant, which is a way of relating the pressures from all the various things, the various gases in there. We can write that like this. And the equilibrium constant is equal to the partial pressure of the products, what we make, in this case the methanol, divided by the partial pressures of the reactants. And the thing you've got to be careful of is you've got to look at the equation. If we've got 2 moles, we have to multiply it by the power there. So actually, in the products, we've only got 1 mole of methanol, so it's the partial pressure of the methanol, CH3OH. And then on the bottom here, we've got the partial pressure due to the carbon monoxide times the partial pressure due to the hydrogen, which is then squared, because we've got 2 moles there, and that's the trick. So all you do then is you work out what the actual pressure is. The partial pressure is, for example, for carbon monoxide, 2.76 moles out of the total of 7.63 moles is the fraction, the part that's due to carbon monoxide. And the total pressure is 630. So you say that the pressure that's due to the carbon monoxide is a fraction of the 630 kilopascals in this case. So what actually is it? Okay, well, the partial pressure due to the carbon monoxide is how much carbon monoxide? 2.76 out of the total of 7.63 times the 630 kilopascals. We do the same thing for the hydrogen and the same thing for the methanol. So let's do all of these. 2.76 times 630 divided by 7.63 equals 227.8 kilopascals. going to rub this bit out now. So got a bit more space, change colour. And the partial pressure for hydrogen, same thing, is equal to 4.51 divided by 7.63 times 630 kilopascals. 4.51 divided by 7.63 times 630 equals 372.3. Go back to the other colour, I think. And we've got the partial pressure due to the methanol, much less. We don't have as much methanol. This is 0.36 divided by 7.63 times 630 kilopascals, which is equal to 0.36 divided by 29.7 kilopascals. And you slap those numbers in, and then you should be able to work out the value of Kp. Okay, well, let's actually do it. This bit, we've worked it out, is the 29.7 equals 29.7 divided by the carbon monoxide, 227.8, times the other one squared. This is the important one, 372.3 squared divided by 227.8 divided by 372.3 squared equals 0.0000094. So that's 9.4 times 10 to the minus 1, 2, 3, 4, 5, 6, and 10 to the minus 6. Now the units are interesting because you've got this is unit of pressure, this is unit of pressure, this is unit of pressure squared. So this is kilopascals, and this is kilopascals, and this is kilopascals squared. So it's actually 10 to the minus 6 kilopascals. This cancels with that one. Kilopascals to the minus 2.